Right, it's pretty much time to move on to the wiring and plumbing and stuff now. The physical dyno itself is pretty much finished, bar a few tie down points and stuff like that. So I brought a conduit across to bring network and power and stuff over here. I'm going to do it a little bit differently to before. So before I had most of the control stuff on like a trolley with the computer, because we used to wheel that around wherever the car was so you could still see the screen. But being four-wheel drive now will mean whether you're doing front drive or rear drive, the car will be in the same place. So I've statically mounted the display on there. Still need to mount the second screen above. So I've got another screen to mount up on top of that. The same screen we had before, just knackered old cheap computer monitors, and this is an old TV, but more than adequate for doing this job. The bigger the better really, you just see it better from inside the car. So we got that all mounted on the pole that you saw us make previously. Just made a bracket, a pair of brackets that come off, and then it just bolts to the VESA mounts on the back, or the VESA mounts on the back of the television. Annoyingly, this really cheap Samsung screen that we had on the old trolley doesn't have VESA mounts. So just in the process of making an adapter plate to somewhat adapt to the original base, I did think about stripping the television down and drilling holes in it, but I frankly can't be bothered. So I think I'm just going to adapt. This is part of the old base that I've just cut out. So we'll make a steel plate to go underneath that, and then hopefully bring a bracket down the back of the television or something. I haven't quite worked out yet, and pick up the same mount, so it should all just bolt on, so we can always move it and bend stuff if we need to just slightly angle the television. It's going to be hard to know until I've actually got a car up on here as to the exact position of where that needs to be. So I'm planning this time to put all the control stuff in the box over here. Before we had, like I said, we had it on the trolley, which was okay, but it's a bit annoying because you end up with cables dragging around on the floor everywhere. So I'm going to put pretty much all the contactors, the hardware interface, or the SP6 in there, and various other bits and pieces. The actual LED brake power supplies I'm going to leave in the chassis, so one in this one in that one. That way all the high current interference should be fairly localized in the dyno, so it isn't interfering with all the load cell signals coming back to that box, because that can be a bit of a problem. So basically the two load cells, the two speed sensors, and then the 0 to 5 volt output will come out of that box to each dyno bed, along with obviously a 240 volt feed for the power supplies that are in the dyno beds. So I'm just mocking up the bracket here now. I did tack it and just quickly hold it up there a minute ago. The idea is I'm going to have two holes in here. They'll line up with the bolt holes that are already on the back of the existing screen. And I've put 4 holes through the base that I can then bolt. This is the original base to that screen, which has got a weird mounting system in it. That'll bolt to there, and then the screen will just slot in like it would on the original stand, or at least that's the idea anyway. I should have actually offset this slightly if I'd been thinking about what I was doing. I was thinking the screen was wider than it actually is, so I'm going to have to put these holes right at the edge to bring it across. It's not going to be worth cutting this apart again just to do that really. So I just finished up that bracket now. I just picked up those original bolts, like I said, which are holding the big screen. Put a little bit of an angle on it just to direct that top monitor downhill a bit, because obviously you're looking at it from an uphill direction. It also then retains the original adjustment on the monitor. Right, what's on guys? Hopefully moving into one of the last stages of this build now. So we're moving on to the wiring and the plumbing. There's quite a bit to do. So there's a certain set of cables that essentially need to go to both of the dyno beds. It's basically the same on the front and the back. Obviously the front is easy because it's fixed, so all the wires can come straight out the control box. So you've got a control cabinet mounted on the upright under the space over here. So obviously all the cables from this rear dyno bed are going to be really easy because they can come straight out run up into there, because that's fixed, nothing's moving. So each dyno essentially has the same cables coming from it. So you've basically got signal from the load cell, signal from a speed sensor. Then there's a power feed that runs to the brake power supply, which is on the side there. Covers are ripped off that one in a minute. So there'll be one of them in each. And there's a few wires for the air solenoids and a couple of wires for the fans. And that is basically what needs to feed both of these dynos. Obviously the back one, because it's moving, the cables need to be extra long. I did consider just having them lying on the floor. I'm sure it would have been fine if I had them just curled on the floor for how often this moves and the slow rate. It would have been absolutely fine to do that. But decided to put a cable track in anyway. It just looks tidier, and it's probably the right thing to do. So we've got a piece of cable track mounted on these supports that we welded on before. You can see I've just ran the first cable, which is going to be a power feed for the eddy brake. So that's just running through the cable track at the minute. I've drilled a hole in the front of the dyno. I'm just about to see there's a grommet to go in there. It's just loose in here at the moment. We'll mount the other power supply in here the same as the other one. So it's basically just a case of pulling all those wires through. There is also an air line that needs to come through there as well, obviously for the airlift on the back dyno. Right, so I've got the ends of all these cables. Right, so we've got the ends of all of these cables pretty much back here now. One anyway. I'm going to mount the brake power supply on the side, just so I know where the cables have got to end up, and I can terminate everything, and then obviously dress it back, so sort of keep it tight from this end, and I'll end up with all the slack at the same end. I've already drilled the holes in this box. A little bit of an awkward place for drilling. Right, so we'll get that bolted in now. Just a bit of a closer look there. So you got your inputs and outputs just on that terminal strip there, and then your control input is up the top there, just on a couple of screw terminals. So we should be able to route those cables up and around. What I try and do is keep the load cell cable away from basically everything else as much as possible. The signal from the load cell is a seriously low voltage, and it is very susceptible to interference. So you want to keep basically that one cable away from everything else. The rest of it can all be ran pretty much alongside each other. It is a shielded cable, so it should be fine, but it's just best practice to keep it separate for as much of the distance as you can. Right, what's on, guys? I think finally it's time to get this wiring sorted out. The videos are pretty much caught up with real time now. A lot of what you saw in the last few videos was filmed over Christmas when I had a little bit more time, and since then basically nothing has happened. So we're going to try and make a little bit of progress over the next couple of days. As I think I said before, we're down to pretty much just doing the wiring and the plumbing to get everything hooked up. So you can see I've started running cables through the tracking as it's coming up through, and then we've just brought them around the frame and left them in a big heap at the front there at the moment. So obviously all of that will be coming up to the control box, which is actually off at the moment. The ones from the front one will also be coming up, along with the connections for the computer, hydraulic pack, obviously the power coming in, network coming in, and a few other bits and pieces. So now that I've ran the cables from the front to the back, it's basically just going to be a job of terminating everything and getting stuff mounted in the control box. So obviously back here we've got speed sensor to mount, make a bracket for that. Mount a new trigger wheel on the end of the shaft. The one that's on the original dyno isn't really suitable. That used to use like an old laser or an LED light system, which is different to the Hall effect sort of sensor that we use now. But wiring the brake power supply, got the cable there ready. Obviously mount and wire in the load cell. That's almost bolt in, just need to make a small adapter at the bottom and just generally tidy it up. Got the air solenoids to mount as well. Got the cables coming through, like I said, up to the front here. So next job was going to actually to rip the control box out of the original dyno. Before, I had a lot of the relays, contactors, power supplies and stuff like that was all inside the dyno, because obviously there was only one of them, so it was all kept inside. But obviously all of that now is going to be moving up into the central control box, which is going to be up here. So we're going to gut that out, cut all the wires off. Most of it will get rewired anyway, get everything out, because we're going to need a lot of what's in that box in the other box. So now that we've got all the cables between the two beds sorted out, it's really just going to be a case of actually physically wiring everything in. So all the sensors and everything in the control box. Now obviously to be able to wire stuff in, it needs to be in its final location and mounted. So we've just moved on to this back dyno now. This is obviously the new one. So this one technically needs updating the same as we did to the front one to work with a modern system. So we already mounted the power supply on the side of the frame. So now I'm just in the process of mounting the load cell, but I just thought I'd show you before I take the old system off, because it's quite interesting. So the way this works, if you haven't watched any of my previous videos, is obviously the car is driving on the front roller, and then the eddy brake, basically just think of it as a big brake. So it applies a braking force to this shaft, which is then directly transferred obviously to the centre of it, which is free to pivot and do whatever it likes. Now originally they had them mounted on these springs, so essentially the more braking force you put on the retarder, the harder it would push down against that spring. So you were basically just trying to overcome that spring. And the way it used to work is there used to be a potentiometer mounted here with a cog on it, which would then obviously turn as this moved up and down. So basically the harder it pushed down on that spring, the more torque being absorbed through the brake would then just reduce the resistance by turning that potentiometer. And that's then what drove the analog dials that you used to see on the old Sun rolling road. They had the speed and the torque as two analog dials, and it was quite literally just fed from those potentiometers. So obviously that is now completely redundant. We'll be moving over to like a modern load cell now. So you can see I've got the load cell here. Obviously I've pulled the cable through into this frame. We've got plenty of slack to route this around. It's just a normal load cell, or strain gauge as some people call it. You can see I've got a rose joint mounted on the top of it. I put that in there the other day just to make sure I have the right one. That will then bolt in place of the top of this spring. Now, not strictly necessary, but what we did on the last dyno is actually have a rubber engine mount. Those of you with a keen eye will recognise that engine mount. Comment below if you know what that's from, but don't think it will take a lot of guessing from any of you. So yeah, we actually mounted that rubber mount originally because we were having problems with coast down, whereby you took the load off the dyno, but obviously at that point everything is still turning very fast. We're having problems with the vibrations, causing a very noisy signal on the coast down from the load cell. Now, of course, you don't want any load cell input on the coast down, because you're not trying to measure torque. You're just trying to measure the speed in which the rollers are slowing down at. Now, they have actually improved the software since then, and it now ignores the load cell on the coast down, or at least there is an option to ignore the load cell on the coast. So this probably isn't actually necessary anymore, to be quite honest. But it doesn't do any harm. You're only ever pushing down on these load cells, bear in mind, because you certainly wouldn't want to pull it up on a rubber mount like that. So I'm going to mount one anyway. We've got one in the front one, and it won't take a lot of extra work to do that. So first thing we're going to do is take this old spring out. I've already pulled the old bolts out. Just set that down there, mate. Alright, so that obviously now can spin right the way around like that. So that's the old spring out. Kind of the same concept. So it's just a spring with a rose joint at each end of it, just like we've basically going to be putting back with a load cell now. So you can see how that centre of the retarder is just free to turn on the centre bearings. So obviously if you were to now run this and put a load on it, this arm here would literally smash down against the floor as soon as you put any load on it whatsoever. So I think what I'm going to do is just cut a little piece of steel, drill a hole in the centre of it, tap it for that thread, and then we can just weld it on the top of this original mount here, each side. That engine mount will then thread down into that, load cell threads on top of that, and that then goes, and then the top of the load cell then bolts into the original bracket. I want to use the original bracket because I did before, and I know the measurement from the centre of the shaft to the centre of that bolt hole, which is critical for calibration. Right, I've drilled the hole out. I'm tap some threads in this plate now to accept that engine mount. So M10 by 1.5. I do.
Alright, just cut that little plate now. Just put a bolt in there so that I can bring this across as far as possible, knowing that that bolt isn't going to interfere with the existing metal, because I want to be slightly offset, because the design of this originally is that the bracket at the top is ever so slightly offset from the bottom, and that's to accommodate for obviously the spring centres not being the same. So I've just offset this slightly to then compensate for that, so that the load cell is looking straight up and down. So I've just been in there with the die grinder and shone off all that metal. So now I'm just going to tack this down in position, or weld it in position, should I say. The centre line forward and back is already centred, so just in line with the bolt hole luckily. So that's got the load cell mounted now, so I've got that engine mount screwed into that piece of metal we just welded in the base of the frame. And we've got that bolted onto the original A-arm. Obviously the cable still needs to be routed and tidied, but that's now mounted, ready to go. Moving on to the next thing, which is the trigger wheel, or speed sensor. So that's what monitors the speed of the front roller, which is obviously very important in the power and speed calculation. So I'm doing exactly the same as I've done on the front one, so they both match. So I've used a cam pulley off an XUD, because that's what I had to hand back in the day, and it's worked absolutely perfectly, so there's no reason to change it. So I've mounted that on the end of the roller shaft. I've just spent quite a while making sure that's exactly central, because obviously that's pretty important, and there's a little bit of play on the bolt. So I've got that running bang on. I've just covered it in paint. I found that was quite useful. When we first put the other one together, we had a bit of trouble with the sensor giving weird information, and it took ages to figure out what the problem was. But initially I kept thinking it was touching. It would basically read speed and then it would freak out and the reading would go all crazy, and we thought it was because it was crashing. So on the other one I covered it in paint, thinking then if it crashed you'd be able to see the mark in the paint. Well, you can see ever since we did that to this day, there's blue paint on this one, but it never did crash. And what it actually turned out to be was, when I first mounted the speed sensor, I think I showed this in my old videos, but it was quite a long time ago. So the original system had an arm like this, but the original system was actually just a light beam. There was a light beam on one side and a receiver on the other, and this is the old trigger wheel here, and it used to send through these holes. It was obviously a little bit less sensitive because none of it was computerized, it was all analog, and it obviously would work fine originally. Now I just took this bracket, so I just welded on a bracket on the top to accept the modern sensor, which is just like imagine it as like a crank sensor or a cam sensor in an engine. It's just a Hall effect sensor. And what was happening is that ever so slight vibration would get started, and it's next to nothing. So if you just imagine the falling edge of that trigger wheel is just coming past the sensor, and this has got ever so slight vibration, that trigger point then goes on off, on off, on off thousands of times. It's hard to imagine it really, because obviously all of this is happening so fast you can't believe it. So if that's spinning at 1000 RPM, that's 4,200 times a minute that one of those teeth is going past the sensor. But if this is then vibrating, every one of those teeth that goes past, it sees that falling edge more than once, if you see what I mean. So it gives you these really erratic speed readings. So you have like a nice smooth curve, and then it will suddenly start jumping around. And it took me quite a while to figure that out, but I eventually worked out because it was because of vibration and this was moving. So what I ended up doing on the other one was just massively beefing up that bracket, just using some really thick steel. Since I've done that, never had a single problem. So we're going to do exactly the same on this one. Just found an offcut of whatever this is, 8mm plate I've got lying around. So I just marked it with a marker there. I'm going to cut this off, turn it into a bracket, which can then be mounted there. We'll weld an upright to that, drill a hole in it, drill a hole to mount it, and mount the sensor in it.
Right then, so I spent a bit of time sorting the wiring out in this rear dyno frame here. So you can see I got the power supply on the side, obviously got the output to the brake, got the two air solenoids wired in, made up a little bracket, same as the front one for the speed sensor, and mounted another cam gear on the end for that to read. And we've got it all wired through, tidied up, so pretty much everything is tied away where it needs to be in there. So then we've got the wires coming up through the track, which we made earlier. And we've just tidied them in around So we've currently just got a big mess of cables basically up here in the front, coming from the back dyno, and obviously all the stuff from the front one is in here. So we're at the point really of mounting up the control box and starting to bring all the cables together in one place, which is generally the last thing I do. So I find it a lot easier to terminate everything at all the ends, get everything sorted out, bring it all back to one central location, and then virtually the last thing you do is just connect everything up once you know where it's all going. So we've been working on the control box over on the bench. Just easier to mount everything on the bench before you've got it in situ and you're trying to work on it sat on top of that box there, which isn't ideal.